Hi again, everyone. I am Jenna from the Rhode Island Intensive Math Intervention Project, and thank you for participating in our module on effectively planning mathematics instruction, how to universally design and differentiate lessons. This module brings together content from past modules and information from the text Teaching Elementary Mathematics to Struggling Learners by Brad Witzel and Mary Little. Our goal in this module is to help you, as an educator, meaningfully plan mathematics instruction for all of your learners. We'll start by covering what is meant by true mathematical learning before moving into some concrete strategies to support student understanding. This module is broken into 4 sections. In the first section, we will refresh the ideas from previous modules and connect the true mathematical learning to the planning process for core instruction. The second section, we will go through an example of how to universally design mathematics instruction using concrete strategies for a specific concept, which likely would occur across a unit or multiple days of instruction, not a single lesson. The third section goes into a specific strategy for solving word problems and supporting learners, which is called schema-based instruction. Lastly, we will recap and summarize the content for effectively planning mathematics instruction. At the end of each section, there will be a reflect and/or discuss activity. Please be sure to complete before moving on to the next section. Thank you and enjoy. At this point, I hope you're pretty familiar with the 3 major shifts that occurred when we adopted the Common Core State Standards for mathematics. They're related to focus, coherence, and rigor. Focus referring to the content is emphasized at a particular grade, coherence being how the content builds across the grade levels. And remember, it's important for math instruction to be coherent so that students can make sense of math and see how it is connected as they progress through the grades. And rigor referring to a balance of math sense making. Its foundation is in the individual classroom. For a more in-depth description around focus, coherence, and rigor, see our first module, Features of Core Part 1, where we discuss how the content and practice standards build across the grade levels. The content standards outline the skills and concepts students are expected to learn at each grade level. We need to know where students came from and where they are going in order to know how to support them to get there. We also need to consider the standards for mathematical practice. These are more like your process standards. In this module, we don't go in depth into either the progressions or the standards for math practice, as they are covered in more depth in our modules around features of core instruction. The point here is that in order for us to support focus in the mathematics classroom, we need to be knowledgeable of how standards progress across grades, as well as the practice standards we should be addressing through our instruction to move students through the content standards. The Common Core Standards started by thinking about the logical structure of math and children's cognitive development. From there, the progression was divided into grade level standards and further refined. Your students have a past, present, and future in mathematics. Even kindergartners come to school knowing something about how math works. Perhaps not formally, but by interacting with numbers and quantities in their life. Standards-based teaching is immensely important to make sure students develop the foundational knowledge now that they can later build on in the future. The math they learn next year and the year after that is dependent on what they have learned previously. Knowing what comes next can help you address potential gaps or trouble areas now, before they compound as the years go by. By understanding our students' mathematical past, present, and future, we are creating coherence in our classroom. Rigor is an area that has its foundation in the individual classroom, so it needs to be purposely planned for in the lesson. Rigor is not the same as giving students hard problems. Rather, rigor refers to a balance of math sense making to lead towards deep mathematical understanding. This triangle shows how the components of conceptual understanding, procedural fluency, and application are balanced to attain rigor. Making sense of mathematical concepts or conceptual understanding involves making sense of the math and being able to reason about and understand mathematical concepts and ideas. Performing procedures fluently, or procedural fluency, including, includes knowing mathematical facts, computing, and doing math. Using mathematical concepts in problem-solving applications, also referred to as applications, is applying what a student knows about mathematics in a contextual situation. Our goal is for all students to be problem solvers. We need to introduce all students to applications, word problems, and other tasks to ensure they are developing strong problem-solving skills. The assumption that math is a universal language can lead educators astray, as they may incorrectly assume that all students can succeed in math regardless of language proficiency. After all, numbers are universal. However, we interact with the language of mathematics in a variety of ways through words like add, subtract, and reduce, numbers, both positive and negative, symbols, operations, parentheses, brackets, and reading from both left to right, right to left, and top to bottom, depending on how the problem is presented. All of these require a command of the English language that not all students have yet. We have to create precise language around mathematics for all of our learners if we want them to be able to make sense of the mathematical concepts. In order for our students to be proficient in mathematics, they must be problem solvers. Word problems, real world scenarios, and other types of problems where students apply what they've learned help achieve this goal. In the previous slide, we discussed why strong, precise academic language was an important foundation to making sense of mathematical concepts in our instruction. It is also crucial for students to have the skills to problem solve and reason about situations. Additionally, educators have to believe that all students are capable and can develop mathematical problem solving. These are not skills that students come to the table with, and they may need explicit instruction and repeated practice to develop proficiency. To build problem-solving skills, problem solving should not be something that only occurs at the end of a unit of study. While students are learning about a topic, if they need to see how their knowledge will be used. This also helps them begin to recognize problem types that are associated with a mathematical topic. In the past, teachers often shied away from incorporating word problems into instruction because they feared they would be too challenging for their struggling students. We now know that providing a context often makes the math more accessible for children, including struggling learners. All learners are capable of developing mathematical problem-solving skills. Application problems often fall into particularly categories that can all use the same approach or strategies to solve them. Rather than shy away or have students skip the application problems for fear of them being too challenging, there are strategies we can use to scaffold the learning. Schema-based instruction, also known as cognitive strategy instruction, can help students make sense of novel problems by recognizing structure. To learn more about various supports for struggling students with word problems, see schema-based instruction resources in the implementation folder, or stay tuned for our brief discussion later in this presentation. Procedural fluency is a critical component of mathematical proficiency. Fluency is often used to refer to automaticity with facts, but there is much more to procedural fluency than just knowing your addition and multiplication facts. Students work to learn these facts not just for the sake of knowing them, but because it allows students to engage with computation and procedures more easily. If these facts are known automatically instead of needing to slow down the process to work through them. In other words, mastery makes life easier, but lack of mastery should not be seen as an excuse to engage our students in rich problem solving. To perform mathematical procedures fluently, it is more than learning strategies, procedures, or approaches in isolation. It's about developing learners who understand what is being asked. This goes back to sense making, and who are able to apply what they've learned to a variety of problems. When we create opportunities for students to make sense, apply, and become fluent and more efficient, we have achieved rigor in our classroom. Engaging in rich mathematical discourse around mental math strategies encourages all students to build procedural fluency, that is, accuracy, efficiency, and flexibility. And it's less important for them to finish fast. Rich mathematical discourse also encourages those learners that have procedures memorized to think about topics at a more deep conceptual level, helping to build a balance in their rigorous understanding of mathematics. When thinking about how to integrate the various strategies learned throughout the modules into our classroom, we need to consider our curriculum. We should take some time and review our curriculum units and lessons. For curricula, we'll want to see if it was reviewed by EdReports, and if so, how it rated. If it has a yellow or red gateway, we should consider if our curriculum units and lessons include, incorporate, and address all of the content and practice standards. If they follow the progression of skills over the course of the school year appropriately, and if there are any areas we may need to supplement. Are there specific standards that we need to go more in depth in? Or take something out. Is the curriculum covering non relevant content? Curriculum adjustments under consideration must be done by a group of leaders and educators coming to consensus rather than a teacher in isolation. If done in isolation, we could be unintentionally causing inequities between classrooms. Essentially, the standards tell us what to teach, and curriculum is a tool to help us address the standards. But what we know is there is no perfect curriculum. We may have various instructional models, routines, small group work, workshop model, etc. in place. You should also review the instructional models you are using, because workshops or small group instruction in and of themselves require thoughtful planning and design around all of the learners in our classroom. Instructional models often provide a structure for teaching the curriculum, but could be universally designed or further differentiated or scaffolded to meet all students' needs. We'll talk more about these concepts as we move forward. Essentially, curriculum is not synonymous with instruction. They go hand in hand. Curriculum is a tool we can use to guide our work, but our instruction cannot be based on a step-by-step procedure. To meet the needs of our students, we need to plan instruction that can be universally designed, differentiated, or scaffolded. In the last slide, we briefly mentioned Universal Design for Learning, or UDL. Hopefully you've heard of this before in our other modules. If you haven't, here is a brief definition. Universal Design for Learning is a framework to improve and optimize teaching and learning for all, based on scientific insights into how humans learn. UDL originated in the area of architecture. A building designer recognized that some features of buildings weren't accessible for certain individuals and sought to change that. That's why we have wheelchair ramps, curb cuts, elevators, escalators, buttons to open door, and even braille on signs, in addition to other features. And it turns out that if you design for those in the margins, your building works better for everyone. The same is true for curriculum. when we universally design for our students in the margins, such as our multilingual learners, our differently abled students, and students with gifts and talents, we can ensure our curriculum works better for all learners. To implement UDL, there are three initial things we need to do. First, we need to identify the goal of our instruction. Start with the end in mind. Then we need to identify barriers for asking ourselves what might prohibit students from accessing the content, thinking specifically about our students in the margins. Lastly, we need to determine how to minimize those barriers. To help us do this, we can turn to the UDL guidelines of multiple means of representation, action and expression, and engagement. We'll talk about these more in depth next, discussing how universally designing for learning using these guidelines helps create flexible pathways for all learners. This is an example of a great tool you can use in your planning of units to identify a clear objective for all learners based on a specific standard, your focus, and then map that focus back to what foundational skills are needed to achieve the focus so you can identify potential barriers that might prohibit students from accessing the content. This example starts at a fourth grade skill, and you can see all of the first, second, third, and even fourth grade standards that build to support numbers and operations in base 10, fourth grade standard. Then you can see that the fourth grade concepts builds to fifth grade standards in numbers and operations base 10, sixth grade standards in the number system, and even concepts within measurement and data domain. So this is an example of why coherence is crucial when we are thinking about planning our instruction. Take a moment to walk through the coherence map at achievethecore.org/coherence-map. While exploring, ask yourself what might be a barrier for the student in the skill that we're currently trying to address that I might not have thought of. Pause the video now. Let's dig a bit deeper. Place value is a foundational mathematics skill that helps students build number sense. Let's say our student is in an early grade working on explaining why addition and subtraction work using place value and the properties of operations. This foundation allows them to progress into the concept that two-digit numbers represent tens and ones, building off what they learned previously around place value. Student knowledge of place value continues to build and progress over time. And ultimately, we would hope that students' foundation that we provided in place value and number sense would lead to our students' ability to solve word problems posed with whole numbers. But what if we're still working towards developing these skills and our students are at the stage where they need to fluently add and subtract multi-digit whole numbers using the standard algorithm? And a group of students is still working towards mastery of using multiplication and division within 100 to solve word problems. And one student is still working on applying properties of operations as strategies. How do we get them to where they need to be? This is the ultimate question. Before we move into the next part where we're really going to dig into specific strategies and approaches, we would like you to reflect and discuss, if you're with a group, on what does your mathematics instruction currently look like? What about your colleagues' mathematics instruction? Think about a typical lesson in my classroom and try to describe what it looks like.